Okay, good morning everybody. I'm apparently the coffee at the beginning of this presentation today. Hopefully I can keep you all awake and hopefully you'll get some information from me that is helpful to you. Just a real quick thing about what we do at Audio Incorporated. We cover a great deal of the audio industry, from rental systems for concerts and big events and political rallies and that kind of stuff, all the way to doing very large conference rooms and programming of very large DSP systems. A little bit more about that later, but when you have a job that's too big to handle in terms of the complexity and whatever, it normally ends up coming past us for either assistance or to actually do the job. So we cover a great deal of the audio business. So what I'm looking at here is, welcome to the beamforming microphone show. Last year it was the Dante show here for the Noise Boys. Today, I think you're going to find as you walk around, everybody here has a beamforming microphone of some kind or another that you are going to be shown is supposedly the latest technology, the latest thing that everybody is going to use, and is going to do everything that you ever needed a microphone to do in a conference space. Don't believe it. It's not true. They are very, very helpful. But, as I keep saying, your mouth, where you speak from, where the noise comes from, is in the front of your face. If you put a microphone behind you, it's not going to sound the same as a microphone in front of you. It's called physics. That's what gets in the way of all of this wonderful technology. You have to put a microphone in a position that it can see the mouth of the person talking in order to work properly. Now you can put it above them, you can put it directly in front of them, you can put it anywhere. A beamforming microphone will help that situation. Will help it, but it will not resolve the physics of where the noise comes from and how you directly do it. But go around, be inquisitive. One interesting thing about beamforming microphones that I found is that it took till last year for microphone manufacturers to actually release a beamforming microphone. Everybody prior to that was a telecoms manufacturer or somebody that was doing something else in our industry that decided that beamforming microphones were easy to do and therefore they should be the first to the business with them. But real microphone manufacturers took till last year before they actually showed you some product. You know who those two people are quite likely. I mean, there's Shaw and Sennheiser. Compare everything else that you see to what they're doing. There are two different, the technology that's been used, this has been used for years. In fact, if you go on Google and put in the word beamforming, it will tell you all about antennas, it will tell you all about sonar arrays, it will tell you about all of the technology that's been used in forming beams, none of it about microphones until you start getting deeper into so it's an interesting technology. It's one that you're perhaps more used to on the speaker side, where you can actually form beams in columns, Rankers-Hines boxes, so on. Now you're seeing it on the microphone side. The two different styles, the fixed beams, so you can actually program where the people are in a room and point fixed beams at them, rather like having an individual microphone for each section. You can break it up like that, or auto-tracking. Auto-tracking being that you can actually follow somebody as they walk around with a beam. The problem with auto-tracking is that, of course, it follows noise everywhere. So really think about how you want to use beamforming microphones before you decide that they're the best. They don't solve the distance problem. The worst problem we have for getting good audio at the far end of a conference call is the distance between the person speaking and the microphone that's picking them up. The further the distance, the less quality in the audio. So just keep them close. Doesn't matter how the technology is getting better. Keep the microphones as close as you can to people. Walk before you try to run. To give you an idea of the kind of jobs, and kind of going back to what Audio Incorporated does, the very, very first job we got with Shure beamforming microphones, the first thing that landed on my desk was one room with 12 of the 910s in it. I mean, why? Could we just do a room with one, and then a room with two, and then maybe build up to it? Don't try and walk before you can run. The idea being that if it sounds great to you using one of them, don't assume that 12 of them is going to sound 12 times better. It never has with microphones, it probably never will with beamforming ones. Wireless microphones. They've done it again. They took away our 700 megahertz bandwidth. A lot of us here probably had to throw mics away, had to sell them, had to exchange them for other microphones, and in the process of doing that, probably exchanged them for 600 megahertz bandwidth microphones, which you now are going to lose. The FCC have taken those away as well. You need to be looking at a show like this to see the kind of technologies that people are putting out there to resolve the issue of the lack of bandwidth of wireless microphones. Don't think in terms of, I like my Shure this, I like my Sennheiser that, my Audio-Technica, whatever. It's really, you have to look at the technology before you decide what capsule you really have to use. There's no point in it being your favorite capsule if the wireless doesn't work. So keep an open mind when you go look at it. It's all to do with channel count. How many microphones do you really need? I mean, there's an old adage that us geezers know, is that the best wireless microphone is one with a wire on it. And it absolutely still remains true. I mean, you know, I've never known sporting events, US Open tennis, on media day, we stand at the front door where all the media people come in, we take their wireless microphones away from them and give them a 6-foot XLR cable. Why? Because with the amount of RF that's running around on that stadium floor at that time, we don't have time for various other frequencies to just suddenly light up just because we're doing an interview on call with Serena Williams, who's 4 feet away. You don't need wireless, don't use wireless. Another story about the US Open later coming on. The technology is rising to the challenge. There's plenty of people doing some really wonderful stuff, from frequency hopping and multiple frequencies simultaneously and encryption and all kinds of stuff. It's all going to come at a cost. This is expensive stuff. Shure knew all about this when they closed down their digital department to concentrate on wireless when 700 megahertz went away. They're in a much better position to cope with 600, but it's still a big problem. There is no bandwidth. Audio processing, DSP versus core. We use the term DSP. DSP used to refer to a particular chip, a sharp chip, that went in an audio processing unit that allowed you to deal with programming things that happen between the input and the output in an audio sense. Well, along comes a company, QSC, who are doing everything in core function. There are no sharks in there because they have decided the way to do it is to use fast core processors and be able to change analog audio, the microphone output. Some microphones now are digital audio, but somewhere there's a transition. And they translate that into code that allows you to build your audio system within it. Now, does it matter if it's a shark or core? The way we tend to look at it is, if it's a very, very big, complicated system, the United Nations, for instance, that's a core process. They want to do so much in that room, there really was no way of being able to fit that on individual sharp chips. And it gave us a great deal of flexibility to do that. However, there are companies that are doing shark-based, DSP-based stuff that have other qualities that are available to them in the programming side that may be preferable to you. I mean, I'm talking about, how do you compare a biamp to zero with a QSC QSYS when they, in a sense, are two different animals. They kind of do the same thing, they kind of overlap, but if you like what biamp does, then go with it, unless it gets really outside of the scope of the product, then maybe you have to look at QSC. Whatever you're happy with, they still all do the same job. There's one particular function that irks us in terms of the way AECs work in these DSP programming. The fact that with a lot of devices, you can't put an AEC where you want in the process. You can only put it where the manufacturer has designed for you to put that AEC. And it's an interesting concept, but only when you get deeper and bigger into bigger systems. For instance, if I had speakers over me that were my fold back, so that I could hear questions from the audience on your microphones. Now, am I a far end to your microphone? Are you a far end to my microphone? And once you get into more complicated systems, do I want to put an AEC between them? Where do I want to slide these things? How do I want to use them to make this room work, or to make multiple rooms work? As I add a room on, do I want to make that a far end? As I take an air wall out, do I want to do those kind of things? We like to play with those, and we've been very successful in that, but not every product will do that for you. I put in the slide, the official handover of the audio systems to the IT department. QSC recently announced that you can run QSYS on a Dell server, and you can do your local I/O locally in the room. So you could have a large network that's really now governed by the IT department, because the Dell server is the IT department, is in their closet. The network switches from the IT department is in their closet. Where do the audio guys figure in that? How are we handing this over to them? Well, it's an interesting concept, but I will tell you that in our first callbacks on any job, or our first problems in any job that we have, are based upon IT issues, IP addresses, EEE stopping Dante working, all kinds of things that are based upon the fact that the IT guys really don't know what audio is doing. It's audio transport, it's not network switches. So it's curious. Keep an eye on it. It's going to go in that direction. It's been going in that direction for a long time. Audio cable is now RJ45, so Cat5e, Cat6 cable. Therefore, the IT department say that's fine. You have to deal with this. You have to come up with a strategy of being able to cope with this. Does this mean that you have an IT department, an IT person on your staff, somebody who knows how networks do work, somebody who can deal with IP addressing and on a large job? You're going to need it, because you can't just leave it to the customer to give you their IT person who arrives on the job site day one, opens up his laptop and says, "What do you want me to do?" You've got to be ready to answer the problems of IT and how that's implemented in all of the jobs that you do. And you're going to find plenty of people out here on the show floor that are coming up with ways of making it easier for all of us. Giant touchscreen. You were talking about touchscreens earlier on, and or displays. One of the things that we've been seeing in the larger jobs, of course, is these massive displays, massive touchscreens that have multiple lines of video going into them. So you've got maybe 5 or 6 different video sources that will show up on the screen. You can move and touch and push them wherever you want, size them wherever you want. It looks very dynamic, looks very Star Trek. Everybody loves the fact that they spend so much money on this great process. And you sit in a small room and you watch somebody do this, and you realize that the video is completely out of time with all the audio. Right? Now, you have to look at that video and you have to decide what it is that you want to make perfectly timed. Because every time they come to a different source, it's going to come up differently on your screen. You're never going to know what those delays are. And the more images you have, the more it slows down. The bigger the different sizes you do, the more time factor gets put into it. You have to chase that with your audio system setup. Now, what we decided to do was, since you'll hear a little bit more about this later on in the day, the fact that people are used to doing their own conferencing, their own video conferencing from Skype or whatever from a simple device, but when you've spent hundreds of thousands of dollars on a touchscreen and hundreds of thousands of dollars on a Cisco conferencing system, whatever, you better have that audio in time with the far end on a video conference call. If there's nothing else that you concentrate on, get that one right. That's the thing that your customer has spent more money on than anything else in that room. And you do not want them to say, "Damn, I spent $1 million on this, and it looks just the same as my Skype call." Tech zones. A couple of years ago, a ceiling tile manufacturer by the name of Armstrong came out with a ceiling tile system that they called Tech Zone. Now, what that system comprised of is a 4-foot square tile with a 6-inch border around it. Now, the idea was that the 6-inch border is where you put your technology. This is where you put your lighting, this is where you put your microphones, this is where you put your speakers, this is where, because we want the big 4-foot square tile to be our open space to look architecturally right, to do whatever it does. Well, then along comes an architect who places the first 4-foot square tile right over the top of the conference table and says, you can't put any penetrations in that, therefore you have to go in the outside. Now, I have my microphones and my speakers now can only be concentrated in this 4 to 6 inch wide panel. But how many 4 to 6 inch wide speakers are out there? I don't know that there's that many that I've seen. Most people are using bigger speakers, so how can we fit them all in there? Now all of a sudden it's our problem to resolve. We have to get clever with what speakers we put in there, we have to get clever with what microphones we put in there. We are being told where the locations of these microphones and speakers can only be, when physics tells us it doesn't work there. So it's already a difficult enough job. It's already tough for us to get these rooms to sound right. Now you're telling me, oh, you can't do this, you can't hang a microphone in front of somebody because the light fixture is 6 foot, 10 foot square over the table. And you're not allowed to do any penetrations in there. Well, maybe we could have discussed something with the lighting designer to get some microphones in the chandelier or in the whatever we're putting in there. But that never happens before the problem actually exists, or other people decide that it's okay, the audio guys will take care of it. We've got these beam thingy microphones, so we hang a dozen of them in the room and, you know, everything will be great. Of course, it isn't. We need to find a way of encouraging people, design consultants, architects, clients, to not make the job more difficult for us, but you have to learn how to come up with the words to explain to them that a microphone only works when it's in front of somebody's face. You can't put a microphone outside the room and expect it to pick up the conversation inside the room. But that's effectively what they want us to do. Microphones, like lights, can only see with direct line of sight to a person's mouth or to, in the case of a light, to what they're reading. Microphones perform the same way. Technologically, they don't bend round corners, they don't do things that the clients hope they will do. Now, what does that do in terms of emerging technologies? The emerging technology is the implementation of the technology of tech zones when they don't work. So how do we stop this happening? Not how do we embrace it? Do we actually say to all of the speaker manufacturers, hey, you know, it'd be great if you made a speaker that would fit into Armstrong's tech zone seating system, when you know full well it's not going to work. Have a look around, see what you can find, see if you see the use of the word tech zone at the show today, and just be aware that this is happening. I'm seeing it more and more and more. Last year's show was the Dante show. This year's show we're going to keep seeing reference to AES 67. Audio transport, it's not control transport, it's not video transport, it's audio transport. Now, I have actually a box of, in my looking around for things to talk about here, I came across a little primer on how audio networks work or how they compare with each other on the Allen and Heath side. It was an electronic document, it wasn't an actual printed document, but the guys at Allen and Heath were nice enough to print up a couple of hundred of them here for me. If you want to see them, it's very, very simple primer on what audio transport systems are out there, how they all interact with each other, and how AES 67 is designed to be the one system that rules them all, or combines them all, or brings them all together. If you want a copy, it's here. If not, go on the Allen and Heath site and you'll find it. It's really very simple. It's not a highly technical paper, but anybody who wants to know how this all works, they can find a lot of information on there. What do we need in a digital transport system? Compatibility, that's why AES 67 is here, and channel count. I really, more and more I hear people say, Dante's wonderful, it's great, you've got 64 channels of audio we can do 64 in each direction. I have boardroom ceilings with more than 64 microphones in them. And so as far as I'm concerned, 64 is not a number that really gets me interested in bigger audio systems. But multiples of 64, I guess, is the way that it's going to work for us. So again, look out there and see what people are doing. Dante will do more than 64 channels, but I think you'll find it's going to be extremely difficult for you to find a manufacturer out here. And if you do, let me know who's using more than 64, using a chip bigger than the 64 by 64 chip, or multiples of that. Let me know, because it could be interesting to us. Network clocking. Please do something for me when you're out there talking to the DSP guys and all the system implementers. Find out what the thoughts are in terms of clocking all of the digital product that we have. The fact that we have a Biam this, a QSC that, the Yamaha the other, whatever system, all in the same unit, and everything is clocking off of each other, or they're allowing Dante to find what it thinks is the most stable clock to govern everything in the room, or you're using a Shure MX wireless system that's decided it needs to be the master clock for hundreds of inputs into a Tessera system or into a QSC QSys because that's the only way that it will work. I know that on my other side of audio, I know that on the performance side, we need to deal with clocking. We need to be able to say, this is our master clock. Everybody's got to adhere to that because that's the best way to stop clock correction noise, to stop the problems that exist when you've got multiple digital things happening simultaneously. Please ask that question. Please get an idea of where everybody's coming from on that. This is one that I need to know, and I'm going to find out at the show as well. But this is an emerging problem, and you've got to solve it. And just be aware that it exists. Questions?
Okay.
How much time have I got?
We have 2 people to start doing this. We've got plenty of time for questions. Who has a question on this side of the room?
I get to throw it at you. Come on.
This is an opportunity to make up something. I want to see these things work. No questions. Questions over here. Nobody has any questions. Got to have them. All right. You got one over there? I'll throw it. All I did is to throw it. I saw one over here. There's one back. All right. Ready? Catch.
Oh, I'm a bad
I knew this was going to be in this. Okay, who had the question over here? Somebody and that's a microphone, so go for it.
I'm black part.
Black part to your mouth.
Yeah.
Do you have a gate on this thing or something? She can throw it?
There you go. Your name and your question, please.
My name's Kevin. My question is with the moving forward with Dante and tech zones and all these things, do you see a shift away from the design side, moving towards the architect on a lot of these AV-centric?
Oh my God. Really? Okay, here's a Sinclair one for you. A few friends of mine are going to sit here in the audience and cringe when I say this. I have never yet met a design consultant who would tell an architect, damn it, you're wrong. I don't want another project from you. but this is silly. Don't do it.
Have you found a way that you can kind of interject your point in a polite, friendly way that they actually listen to at this point?
I'm sorry, but there isn't a speaker on this. I'm sorry, say that again?
I was just curious if you found a way that there's a polite, friendly way to interject your point that's taken so far.
Yes. Yeah, you've got to, one of the positions that we take quite often is to be an audio consultant with the AV consultant and the architect, but on behalf of the client. So I'll go and take a meeting with an architect and I can be the bad guy. I can tell the architect, because I have the architect doesn't employ me, doesn't throw me work, doesn't give me anything. It's the client that pays me, and I have to tell the architect, no, it really doesn't work like this. You can't put this line array speaker system behind a 3/4 inch thick plywood cover with 50% perforation holes drilled in it, because it can't be done. Take a flashlight and shine it behind that 50% perforation. Now tell me how you're going to point it down or point it up, because you're actually putting my sound system through a whole set of tubes. And if it's 50% perforated, then I guess I need to double the size of my sound system. Now, the architect may not like me for being obvious, but, I'm sorry, that's what we do. And we still have clients.
Let me take one over here. I know somebody over here question. Who's got the cue? Okay, it's on.
All right. Michael, just listening to you speak tells me you've lived in the real world of audio and audio designs. I do always have issues with clients not wanting to have microphones on the tables. They think audio is magic and we can get it to the sound system without microphones. Kind of reminds me of the rock and roll band, and the guitar player says, don't mic my guitar amp, but give me a little bit of monitors. We can't do that. And obviously, the end users here have to understand that we live by the laws of physics and we have to make that happen. And the other headache there is sometimes the vendors, I want to say, hypersell their products, that it's magic and it's the answer to all, but it always isn't. And you hit it right on the head. It just isn't always the answer.
Thanks. I mean, I don't know if there was a question in there, but I appreciate that.
How do you sell that to the end user? How do you explain to the
Well,
end
what
user?
you're trying to do, what I try to do, is to explain to the end user that what we're doing is actually really cool. I mean, some of the most amazing things we've done may not look, really sexy to people, but we're really, really pumped about the fact that we actually managed to make things work. I tell you, the first time you do a ceiling array of maybe 50 microphones and 50 speakers, and you're doing a mixed minus voice lift across the room, and it works, and you finally figured out how to do that, that's incredible. That's absolutely incredible. Now, the customer sees all the microphones and they see all the speakers, but if you're really enthusiastic about how this is happening and you can show them that it works, you turn it off and they hear it without it, you turn it on and they hear it again. And you go, see how incredible this is? And you guys have got it. You actually have to be a salesman to the technology that you're selling, which is the programming and the setup, and how all this works. Be excited about it. I mean, this couldn't be, in my lifetime, the audio system is the most exciting change of technology. I mean, there's so many people of my age that are still sitting there going, well, those analog consoles, they sound so much better than the digital ones, and and I just couldn't mix Aerosmith properly without doing it, and it's really, I mean, if I hadn't have said, I love analog consoles, I love Rupert Neve stuff, but it's great, I've bought so many analog Linux consoles in my life, they're I know these things, I love them. But it didn't mean that I stayed there. If I wanted to keep eating, I needed to understand how digital works. And it's exciting to me. I mean, I'm excited about in a couple of weeks' time, I actually get to sit behind a Yamaha Ravage and mix a show again. Fantastic console. Now, does it sound better than, worse than an analog board? I don't know. It sounds different, and it will sound great. Just be excited. It's a great time.
I want to thank Mike for taking time to be with us today. For any of you who have other questions and wish to speak with him, he's going to be across the hall.